So I'd also just like to say that now this meeting is being live streamed on YouTube. I will share the link in case someone is not able to get in but still wants to access. So I'll just put that in the chat box. Shall we start? If I think we've got over 20 people here. If that's okay with both of you, we could start. I know a few people have been logged in quite early on.
No, that's okay. But if 4 is the time given to people, then we should wait till 4 o'clock.
Sure, no problem. Okay, shall we start? Yeah. I want to sort of start off with setting context in terms of, a lot has changed in the last 2-3 decades, even from a perspective of waste generation. And sort of to um, say that why should we still move on to decentralized, and just to get a couple of opening comments from both of you. First you, Dr. Karve, and then Anil. Why do you feel like decentralized is the way to go? And it's something that's been suggested year after year after year, decade after decade. And all of us are still very, game on saying that yes, decentralized is that, but it'd be great to hear why both of you feel that.
Okay, so I think decentralized is the only thing that makes logical sense, because the moment you want to aggregate waste in one location to process it further, you are going to be burning fossil fuel to do that aggregation. So there itself, your carbon emissions start coming in. Also, in an urban context, you are adding to the city's pollution by all these garbage trucks moving around all over the city. So that is one very fundamental reason. Uh, also, I mean, in the current world, which is challenged by climate change and also sustainability concerns, we want to move towards waste minimization. And the minimization will also happen if people have to deal with the waste themselves. So that is another reason for promoting decentralized. There are also, I mean, what you call decentralized also is very relative. I mean, from a renewable energy perspective, a city level garbage treatment also gets called decentralized, because you are not doing it at a, let's say, district level. But ward level is the maximum that waste should travel, not beyond that, municipal ward level. Ideally for organic waste at the source of generation. That is what makes sense, because there's just no logic, especially given that there are technological solutions available for decentralized waste management. There is no case for transporting organic waste. That's what I feel.
Anil?
Yeah, so I think just to add to what Dr. Karve just said, I think I want to add the context of some numbers. So when we, let's say, talk about the kind of waste that we generate in our cities, if we, there are some conflicting numbers that are going around. So, for example, a 2016 study from the central government said that urban India generates about 62 million tons of waste on an annual basis. Okay, so just to kind of put, these numbers are so huge that we can't really imagine what that really means. So, we generally what I try to do is to try to fix these numbers in the form of something we can recognize. So let's say if we were to talk about the Statue of Unity and its weight, we're talking about something like 30,000 statues of unity equivalent of waste being generated every single year in India. And that's a very conservative number, just focused on urban India. And then if you extend that to a study done by the World Bank, they actually go ahead and say that we are doing something like 277 million tons on an annual basis across the country. So that makes India the single largest absolute quantity waste generator in the world. Okay. And now if we were to study that in the context of what is really going into that waste. So what's interesting to see is that 60% of that waste is actually organic waste. I mean, it's the biggest share. And that can actually grow even larger when it comes to rural. It can grow in our certain parts of the city. We've even practically measured things. And it can even go up to 70%, 80%. So to actually transport, like Dr. Karve said, transporting 60% of the waste that's being generated actually doesn't make sense at all in any calculation. Okay. And the next thing would be to to actually aggregate all of that together leads to huge amount of complications, because then keeping the quality of that waste becomes a challenge. The kind of the sensitivity of the entire process becomes very critical, because let's say you've got a situation where, uh, for example, a flyover is being constructed, maybe your waste will not be collected, a traffic jam somewhere, and so it is that sensitive a topic. And obviously organic waste is the one that's the most difficult to manage with regard to the potential odor issues, the kind of leachates it generate. The whole hygiene factor is so critical that when we break the problem down into smaller units, it becomes easier to uh, handle it at source. That is also one of the issues. So it's about the administration of it, and the governance of it also becomes simpler. And when it comes to, if you were to study the costs of a municipality to do this kind of work, then you realize that very expensive resources are needed to actually organize this, because as cities grow, the distances that you have to transport also begin to grow. And so the complication just gets amplified. And so ultimately, breaking the problem down to smaller bits and then handling it at source also generates quality resources and value that can come back into the soil, for example, or come back into some kind of resource. So actually, I don't see anything really going for centralized systems when it comes to organic waste. So it has to be either at source or at maximum at the ward level, is what I feel.
I like the fact that both of you sort of spoke about kitchen waste or, household wet waste, biodegradables. But maybe share a little bit of light in the context of also garden waste, right? So we know how dynamic kitchen waste is, but, garden waste is a completely different ball game altogether. Again, in the same order, if you could just share some thoughts.
Yeah, so actually it is important to make these distinctions between what I mean within organic waste, what are the various types, because you want to deal with it at source. Generally what happens is when it is all getting collected and has to be handled in a centralized manner, it doesn't matter. I mean, the technological solutions that are available, so-called solutions, don't really care what kind of organic waste is coming in. But the moment you want to do it at source, you have different solutions for different type of organic waste. And kitchen waste, or sort of green looking organic waste, has nearly 80% moisture in it, and therefore there are only certain ways in which that waste can be handled. Whereas typically garden waste would be leaves that have fallen from trees, or uh, twigs, branches. So generally brown looking waste that has only 10 to 15% moisture, and therefore there are different technological solutions for dealing with it. So once you decide that you want to deal with waste at source, you have to be mindful about what is the whether it is a green organic waste or a brown organic waste. The moisture content becomes very, very important to decide how you want to deal with it. And also another point why, again, it is because of the moisture content that transporting waste and then processing it centrally is a big no-no, because especially when it comes to green waste, you will transport it and 80% of it will actually the even if you are making compost out of it or biogas out of it or any other fuel out of it, only 20 to 30% of the material that you have transported is of any use to you. So that sort of adds to the overall energy spent in dealing with the waste. Whereas if you are doing it at source, you don't have to worry so much about that aspect of it. But different technologies for different moisture content.
Yes. So with regard to garden waste, right? I mean, so uh, uh, absolutely right. I think the point is that we have to clearly distinguish between these two organic waste streams. And again, they are also and another reason to consider garden waste differently is because there is a lot of fluctuation, and in terms of really understanding quantities becomes a very big challenge in the city context, because of seasonal variations, because of the fact that in certain seasons you have huge quantities of garden waste being generated, and other seasons just maybe after the monsoons and so on, it's not going to be that much. So to commit resources to garden waste on a municipal level, again, is a challenge that most cities cannot afford to deal with. And for that reason, we see that in our municipal context, garden waste is a much ignored waste stream. Also, the need to address garden waste is equally critical, because from a climate perspective, if it is not dealt with, uh, the tendency is to actually hoard it and burn it, because it's the only way to actually deal with it in a cheap and easy way. And we've now really, I think, as Indians now, because of the state of Delhi, we've really begun to understand what this can do to a city in terms of when certain types of waste, now we are talking about agricultural waste also contributing there. But the point is, it's a similar waste stream. And if you look at, I mean, my experience has been that in most uh, waste management discussions, and when it comes to any sort of administrative capacity building or so on, garden waste has no presence at all. There's nobody really talking about it. It doesn't really commit any importance when it comes to the resources that are allocated to it. And so generally, this is one of the reasons to also look at a decentralized approach, because you're not going to get the kind of services that you expect for collection of garden waste anyway, and we cannot afford to burn this in the kind of quantities that we are currently dealing with it. And obviously, considering all these fluctuations in quantities. So for that reason, I think these are the three reasons to consider all options that we can put in front of us to, in an affordable and sustainable way, to handle it wherever it's being generated. And maybe again, use the resource value to add to actually a positive shift to contributing to a better environment.
So both of you interestingly touched upon this piece of space, right? Whether it is space in terms of what it actually takes to transport, but also, when you say that no, you have to manage this in your backyard, the first question that most people will say is, "Kitna jagah lagega? How much space will it really take?" And that sort of becomes a make or break kind of a deal, especially in urban areas, because we're already like going, they're high rises. There are very few spaces left, in the corners of the building. There's either parking that takes precedence, or, just pathways to just maneuver around the buildings. So and here I think sort of sharing photographs in terms of how much space, what technology, a little bit of that context setting will really help others understand. Also from a developer's perspective, right? So Pune is also seeing a lot of redevelopment. So are a lot of other tier 1 cities. And so when these plots sort of go into redevelopment, you need to understand what would that space dynamic really look like. And what could that possibly be for for any real estate person who's trying to do that today? Because this definitely will be a value add in terms of getting them green certification, in terms of amplifying the green value of the property in itself.
Yeah, that's very true. And it also is important to understand that I mean, when it comes to organic waste, there are various ways to deal with it, and each one of them will give you a usable product which you can put to use to serve a certain function in that premise. So there are a couple of things that one has to think about. One is to make a sort of a guesstimate as to how much of what type of organic waste will be generated on that land, and that depends on how many people will be living there, or if there are commercial establishments, what kind of commercial establishment, if there is a I mean the garden space, what the in which way it is being planned, all of that sort of factors into this. um, and what services will be valued by people who will be using those premises. So if it is a residential society, for example, then there is now the option of converting your kitchen waste into biogas. That biogas can be used for cooking in some of the kitchens, if not all the kitchens in that society. So or in on that premises. So all of these things will have to be planned in advance and incorporated in the construction. Even the kitchen design has to align with the fact that it is going to use biogas, for example. Or if compost is going to be made, then where is the space designated for that, and how much quantity, the maximum quantity that that system is expected to handle. So that designated space will have to be left for that. I mean, many times unfortunately what happens is that just because it is mandatory that something needs to be there, so just for the sake of showing some small piddly thing will be put there, the cheapest that the developer can get hold of, and that sort of tick marks and moves forward. But then when it comes to actually using the space, then it becomes more of a liability than a solution. So to avoid that, there are, I mean, it is genuinely possible to incorporate realistic solutions in the in the design of the space itself. And if it is incorporated while the construction is happening, it will also be I mean, the cost will also be less, and the operating cost will also be less, because the system will be customized to the requirements of that premises. So all of this requires a lot of thinking through right from the moment that the construction plan is being developed, according to me.
Anil, I'd also like you to share while you are, sort of putting in your comments about how, when we look at design in itself, and there are a lot of these concerns about environment compliances that developers, realtors have to sort of take that into consideration. I know you've got some first-hand experience. So if you could also just integrate that here, will be very useful.
Yes. So when it comes to space, right, I think obviously, like Dr. Karve said, the first thing is really to assess the quantities, and that can be sometimes challenging. But ultimately, when it comes to organic waste, there is some level of thumb rules and some things that go well, because it's a rather more reliable and regular kind of generated waste. So when it comes to residential communities, what we do when we implement projects is to really look at the number of families that are staying there, and we've got I would say, a rough guesstimate in terms of how wastes are being generated. On that basis, we have a clear understanding if we were to do composting, which is basically our method of dealing with organic waste. So we look at uh, identifying the right space based on the quantity. So for 100 kg, let's say 120 household community, we would probably need something around that would be 75 kgs of waste on a daily basis. And we would need to allocate a space of around somewhere between 150 to 200 square feet of space. Now, this is a little bit easier to plan, right? But when it comes to garden waste, we found that practically it's not so easy to plan this the space that's needed, even after actual surveys, and because of the seasonal variations. You have to really understand what is growing there, what kind of trees are growing there, and what is the seasonality of those trees, what is their life cycle. Then you may have other shrubs, you may have garden lawns, all of that. And to really put all of that together and really understand what kind of quantity of garden waste will be generated there. We've personally found it a little bit difficult to estimate. So normally what we do is put, try to go on the seasons where, we definitely know that the leaf fall is much more, and try to set our capacities at that level so that we don't, on the leaner times we can manage things. This is the kind of approach. And in a urban context, we have found that when it comes to space, we have to think about two approaches. That is one, like rightly as Dr. Karve said, see, if we were to get right in the beginning when developers are planning the place, and we were going to set this right from the drawing board, it would have been very easy to do this, much cheaper, and the long-term results would really show, and a real impact could be created in the long term, where these waste streams never need to be transported and never need to enter into a landfill kind of a situation. But let's say we take the second situation, which has become kind of the norm for us in most of our projects, is to really retrofit the solution, because it has not been planned or it has not been thought of right from the drawing board. So in these cases, we have to actually end up reimagining the way we think about spaces, and that's where we do a lot of work with the communities that we engage with, and the idea is to actually think of the spaces that are wasted in the community, like corners, like spaces between compound walls and gardens, elongated spaces where there is no other actual utility for that space. There could be basements that could be used. And I want to share with you some quick pictures on this, on how we've like thought of these designs in a very practical, simple way, where we can really, get results with a retrofit sort of a situation. So I'm just quickly going to share my screen. Um, okay, I hope this is visible.
Visible.
Let's go into screen mode. Yeah, visible.
Yes.
Okay. So I just, for example, wanted to give you the context of now the kind of high density urban constructions that are now going to be the future of the way we plan our cities. At least that's how it's looking right now. And in this context, what happens is we've got a very small area which is going to house maybe uh, anywhere between 800 to 1,000 families, and that's like going to be the norm, the way construction is going on, if you see on the peripheries of most of our urban environments today, and the way cities are developing, and the way newer zones are developing around the cities, mainly going further away from the center of the city. So here, what happens is we are looking for very simple constructions like these, which are affordable, easy, and now we are throwing open all the creativity to developers to think about using new kinds of materials, creating new kinds of, I would say, aesthetics in terms of how the design is implemented on the composting or the waste management side. And looking at long, elongated, but narrow spaces, which we can use, put it to very good use. And this could be things like, we've refit solutions in housing complexes. This is a 300, almost 400 flat community where initially they had like a room to distribute their LPG, which now has been converted into a composting facility. So the solution here is very affordable, very cost effective, because you've got all the room available. You can make sure that there's good amount of air circulation, and you get a fantastic result from such a unit. I'm sure Dr. Karve can also talk about a similar room like this for biogas. Imagine if, let's say, we were to have a biogas implementation here, where the building already has a distribution channel for all the gas set up, because LPG was being used before. And now that LPG has gone away, you could consider distributing biogas through such a system.
Yeah, definitely. It would
Absolutely.
have worked quite well there. Yeah.
Exactly. So I think a similar kind of an approach could be taken for biogas. Then where absolutely difficult situations are encountered, we are using simple containers. We are also looking at the rooftops to be used with basic fabricated structures to do composting on the terrace if it is not practical to look at the ground level implementation. And then particularly, we've also used spaces between compound walls and parking spaces. And initially, this looks, quite a challenging task to convince people to go for such spaces, because the general feeling is that when organic waste is going to be treated, it's going to be unhygienic, it's going to spread odors, there's going to be flies and pests and mosquitoes, and and probably it's going to become a health hazard. But what we are looking to do is to work with the communities that we are engaged with in a long term sort of arrangement. So the pictures that I'm showing you are communities which are anywhere between 500, 300, 200 family communities, and where it's possible to run these sustainably. These projects are now running 5 years, 6 years continuously, and we've built in a service model behind it. And it's not about just setting up something and allowing the community then to deal with it, because these are, see, all biological processes need a lot of intervention to run them sustainably and in the long term. Because of the kind of variation in the waste, because of the kind of inputs that may be changing seasonally, it's not something that can be just handed over to somebody and for them to be expected to run it sustainably and long term. So we intend to provide a long term service model that ensures that, once the community invests in such a story, then they need to be able to run it long term, and then really the long term results are there to be shown. Tons and tons of compost can be generated, gas can be generated, slurry can be generated, and then all these resources have to be looked in for their own value that they can bring to the community. So here are more pictures, like, it can be even integrated right at the parking level, and where you generally don't imagine where organic waste can be treated. So these spaces need to be reimagined. People will never think that this space is actually space for waste management when you actually talk to them, but you will have to implement it, maybe do pilots and show them and convince them. And there's a lot of that convincing work that is required to really convert communities to go for efficiently using their space. So I think this is the other story when it comes to retrofit solutions. Obviously, these two approaches have to be taken at their own value, and finally the results are there to be shown on the ground.
Thanks for sharing, Anil. Dr. Karve, maybe if you would
Yeah.
like to also show a couple of photographs.
Yeah, but before that, just a few comments. I mean, few basic principles that we have to all understand. As far as uh, the household organic waste, that is the kitchen waste and food waste and all of that is concerned, and when we are talking about dealing with waste at source, I think compost and biogas, these are really the only two realistic options there, and both of which are driven by microbes, where the microbes are using, I mean, their metabolism is taking care of the waste. In both cases, different types of microbes are involved. And that is why our energy input in that case is less. And that is the ideal way to move forward. I mean, microbes are our most ancient living organisms on the planet, and if they are willing to help us deal with our waste, then we should take maximum help from them. And that is why I'm totally against any solution which uses electricity, because that is wasteful. When you have this entire living organisms who are willing to spend energy for you, why to create energy by burning a non-renewable resource and then use that for dealing with waste? So that those type of solutions, I think, are totally wrong. and should be totally avoided. So that is first basic principle. Wherever possible, get the help of microbes. As far as garden waste is concerned, and as has been pointed out, it is the trickier type of waste because the quantity keeps on fluctuating. And one problem that we have also seen when it comes to housing societies, or in general, commonly, I mean, public premises or semi public premises, the garden waste will have a lot of plastic and paper and all whole lot of other things in it. So some level of segregation has to be there, and that creates another challenge in dealing with garden waste, apart from the quantity and variations in types. You have everything from grasses to big branches. And in just to complicate the whole thing, even our kitchen generates some of the materials which actually should be treated as garden waste, like coconut shells, for example. So as I said, brown waste and green waste is a better way to classify these. Now as far as the garden waste is concerned, some of it can be used along with the kitchen waste to control the moisture, for better composting and moisture and aeration and all of that. So some of the garden waste can then help in the composting of the kitchen waste rather than adding something else into that. Um, Remaining, and especially when it comes to woody biomass, and unwieldy geometries, even in dried leaves and things like that, there it becomes a bit difficult to handle. Also in winter season, when the trees are shedding a lot of leaves, the composting system can get overwhelmed, even if you have designed it for fairly high quantities, because the trees, as they grow, the shedding of leaves also increases. So and people may be planting more trees, and the garden gets changed also. So even if you may have done some estimates at the beginning, those may go wrong. So a subsidiary technology therefore is required along with composting, and that is where I think biocharing is a good option. This does not involve microbes, but you can do biocharing using energy from the waste itself. You don't have to use an additional external energy source for that. There are various ways in which one can do biocharing. A lot of misconceptions also about biocharing, because there is a flame involved. Many people feel that this is just burning of waste, but it is not. It is basically converting the waste into a gas, and then we burn off the gas. If we allow it to go out without burning, then that is going to cause pollution. So you burn off the gas, and then you are left with char, which combined with compost becomes actually a more effective additive for your garden soil. So I will just share a few photographs about the specific technology that I'm talking about. But as I said, there are various ways, various techniques in which one can do biocharing. Just give me a minute. Okay, I hope this is visible.
Yes.
Yeah. So what you are seeing here are basically pieces of a double walled box. When these pieces are put together, this is what you will get. The idea here is that this is going to complement your composting system primarily during the winter season, and therefore you may need to put it together when you need it, and then put it away when you don't need it. And space being a constraint, it can be broken down into pieces and then stored in a very small space. When it is put together, it is a box basically like this, in which you can put your garden waste, which is left over after going into your compost pits and all of that. So as you can see, this is a double walled structure here. The inner box is what you have to fill. Now here you see it only half filled, but you can fill it right up to the brim here. And this what you see here is some kind of a woody waste, but it can also be dry leaves. It should not be packed. It should be loosely filled into it, so that there should be air pockets inside, because that is going to help in the gasification process. And then you just light it from the top, just the top layer. You have to just put a burning piece of paper or something like that. Only the top layer will actually burn in this case, because the way this is designed, it is going to get air through this gap between the two boxes, and that air will only come at the top, and therefore when the top layer of this biomass burns, that heats the layers below, and gasification happens, and combustible gas comes out, which comes in contact with air in this top space here, and that is where it is going to burn. So what you see here is not a very yellow flame, the kind that you get by burning wood. The flame is more sort of reddish bluish kind of a pale yellow kind of a flame, and that is an indication that what is burning is not the solid material itself, but what is burning is all the pollutant gases that are being driven out from the biomass. So once this flame stops, that means all the gases have been driven out, and then you can just lift this box. The box has no bottom, so you just lift it and put it aside. You will get a burning heap of char, which on which you can just sprinkle some water with a rose can to douse the fire, and that gives you your char. So this, if your starting material is woody, then this is how the char will look like, and if it is leaves and grass and things like that, then this is how the material will look like. So in an urban setting, the simplest thing that you can do with this material is, as I said, put it in the garden soil along with the compost. What the char does is it has the capacity to hold moisture, so it will reduce the water requirement for your garden. In addition to that, because your starting material is I mean, we are not using hard wood here. This is all a very lightweight, low density kind of material, and therefore the char also will have a lot of porosity is there. So it increases porosity in the soil, allows more soil bacteria to reside in that soil, and in general improves the fertility of the soil. So this is a much faster way of dealing with the garden waste, because this one lot, I mean this one batch filled in here will be finished in about 15 to 20 minutes. So every 15 to 20 minutes, you can deal with about 3 to 5 kilograms of waste material, and it will leave behind just 1 or 2 kilograms of char. So the volume ultimately that you are dealing with is quite small. So it's one way, especially during winter. As I said, every day the leaves are falling down, and your composting system is slow, and in winter it slows down further, because the bacteria are operating at a slower rate at lower temperature. So a lot of leaves are going to just pile up. So instead of allowing them to pile up, you can just convert that extra leaves and woody material generated in your garden, just convert it into char. And then there are several other things also that you can do with it, but the most simplest thing is just to put it in the soil. So this is one possible solution that one can do. What I showed you is perhaps suitable for a small apartment complex or a bungalow or something like that. But a big, I mean, garden waste becomes really challenging for institutional campuses, like large educational institutes or research institutes in Pune context, or factory premises also have a lot of trees. So these are the kind of spaces where you may be generating 100, 200 kilograms of garden waste on a daily basis. So this is a large kiln that we designed for such applications. It's the same thing, only increased in size. And then we have mounted it on the table because you can't lift it to remove the char. So there are doors at the bottom here. So when you pull these rods, the doors just open and the char will fall down in this tray. You can see here that this kiln is in operation. You hardly see the flame here. Where my arrow is, there is a flame. You can see the burning happening here through the holes. So there is no smoke, and this is working quite nicely. Hardly any visible flame is coming out. So all the gas is burning up nicely, and char will be harvested in this tray here. So both these systems, as you can notice, are metallic, which means that they are portable. And that again is to address the thing that the garden waste is variable. So whenever you have to deal with the garden waste in a particular location, you bring the kiln there, assemble it, deal with it, and then you can move it, store it somewhere else, or take it to some other location. This kiln also breaks down into pieces, which can also fit into a three-wheeler tempo kind of a vehicle, and can be easily carried from one location to another. So this is a good solution, and these are some other things that you can do with the char that is produced. You can convert it into char briquettes, which can be used as fuel for your barbecue parties in the housing complex. Or we have also designed a steam cooker which uses this as fuel. But even ordinary charcoal stove, you can use this as fuel. This is another interesting application. Again, this is more useful perhaps for institutional premises. You just take a cloth bag, fill this char in it, and hang it in the toilets and other closed spaces where you get a sort of a stuffy feeling. So it absorbs all the aromatic compounds from air and gives a freshness to the air circulating in that space. So this is our biochar based air freshener. And if you have a possibility of some kind of an organic soap manufacturing happening nearby, then you can simply give the char to them and they can make biochar soap. So there are various other products which are sellable that can also be made from this biochar. So one interesting business model is again that somebody who is doing the garden waste management can convert the char into various even more value added products, and that becomes another income stream for them in addition to the service fee for handling the waste on those premises. So this is I think a solution which nicely complements garden waste management by composting.
Like even for biogas, right? That would be true for both composting and for biogas.
Well, not so much for biogas, because for biogas, you typically will be using the kitchen waste. That has too much moisture to be charred. So biocharing works typically with material brown organic waste, which has low moisture content. So biogas and composting for green waste, and biochar and composting for garden waste. That is how these combinations can be done.
Sure. I think we're very nicely shifting to the idea of technology, right? Often, and we've all been witness to this about what is appropriate and what is like really not appropriate technology. Some insights from both of your experiences will be very useful. Dr. Karve, first you and then Anil.
Well, as I said, don't use electricity for waste management. I mean, that's any technology that relies on electricity is a total nonsense. In the case of biogas, also again there were a lot of misconceptions. People only thought that you can use fecal matter to generate biogas, but actually with kitchen waste you can generate very good quality biogas with very less space compared to a dung based system. Just to give you a sense of the differences there, 40 kilograms of dung has to sit in the biogas plant for 40 days to produce 1 kilogram of biogas. Whereas 1 kilogram of sugar or starch within 24 hours will give you 1 kilogram biogas. So our food waste, even given that it has 80-90% moisture, you can have 5 kilogram of food waste going into just a 1,000 liter water tank sized biogas plant, and that can even sit on your terrace, because the gas, I mean, through the pipes the gas can go either from top to down or from down to top. So it's the converting food waste into biogas is also a very good technological solution, fairly simple to operate. Now there are user friendly, very user friendly technologies that are available. Service providers are also available in many cities across India. So that is a good option, but you have to figure out, because the total waste generated by the building is not enough to fuel everybody's kitchens. It is going to fuel either partially everybody's kitchens or a few kitchens 100%. So how you want to use the gas is, it's more of a social engineering problem rather than a technology problem. For composting, as I said, make use of microbes. That is the best way to do it. And for biocharing, I already showed you the best technological solution. It must be portable, rather than, I mean, there you can even make a pit and do charring in that, but it's a slow process. It's more polluting process. A well designed charring kiln which is portable is ideal for, especially in the context of urban waste management.
Anil?
Yeah. So I think to add to a little bit in terms of what are the technologies that are really uh, to go for, and what are technologies to watch out for a little bit. I completely agree with Dr. Karve. Staying away from electricity, I think, is the first priority. And there, when it comes to the kind of composting solutions that we are offering, our tendency is always to go with the least amount of mechanization, and to go with maximum usage of microbes, to really push on a traditional approach to composting. Now, when we bring this topic up, I think there are a couple of challenges to face as well. In the urban context, obviously, space is at a premium. And the general impression is that composting will take a lot of space for the treatment of organic waste. But now, with the experience that we've had in the field, with various technologies and various solutions that are now available on composting, I think our experience has been that the impression of how space is being used in the treatment of organic waste, there is a lot of debate and discussion on that. Now, if those things are brought in a very transparent forum to really understand properly and calculate the kind of spaces that are needed, you will I mean, the actual story is that there is not that much difference between composting or any other mechanized methods of composting. Because ultimately, what is the mechanized method of composting doing? It's just, what can it do? It's like, for example, in our human digestive system, if you were to take an equivalent, the machine can just about do the chewing, but it can't do the digestion. Okay. So at the end of the day, the microbes are needed to do the digestion. And if we are going to use machines, yes, they can compress the space a little bit, but appropriate mechanization is what is needed, considering the kind of electricity use and there we cannot afford to use extensive technologies which are going to consume electricity. For example, there was maybe 5 years ago, there was a trend developing for kind of dehydrating organic waste by using electricity, and the so-called 24-hour composter, which ultimately now has proven that it really doesn't work. And the kind of electricity consumption that it's just not affordable for anybody, let alone the kind of climate impact it's going to have. If we are going to use a fossil fuel based electric supply to run a waste management system and to get literally ash out of it really just doesn't make any sense at all. Okay. Going forward, I think there are other mechanized methods. Our tendency is always to look at the lowest level of mechanization that brings the highest amount of efficiency. In certain cases, we have to go with mechanization only because we have to meet with the kind of space, aspirations or the understanding of the people, the waste generators who are going to process their waste. I think here I have a suggestion for developers who are looking to a long-term story around sustainability. I would suggest to look at overall making a deeper understanding of space utilization, because where we have found when it comes to mechanized composting solutions, the tendency is to think that is actually compressing the space. But if you were to run the entire project, you will see that organic waste has to enter into the machine, it has to come out of the machine, and obviously that material has to be stored somewhere. And if you are not going to make the space for storing that material, then again you're talking about a transport mechanism that has to take that material out away from the compound somewhere else. And that's really how space efficiency is not about bringing in the component of transport into it to try to sort of bring in efficiencies. Those are not the real solutions. So if you were to really think about space efficiency, then you have to think about how that material is going to be stored in the compound until its use, and until it is really cured into in the real sense being compost, not in some form that is pre-composted, or it really has to finally smell like soil, the fresh soil that we smell on in the first monsoons. That's really compost. And until you bring compost to that kind of quality and then convert that into a resource, the kind of space that's needed for that has to be accommodated for in real terms. So when you make these kind of comparisons, then you come to an understanding that when it comes to cost and space efficiencies, composting is still really the solution. It really comes to that sort of a solution. And I think that's really about it. I mean, it's about finding the appropriate technologies. And the next thing is to, I would say to a larger extent, avoid burning, but in the context of biocharring, obviously that doesn't qualify really as burning. So from that perspective, I think these two technologies have to be considered on a longer approach when it comes to sustainable waste management in highly urbanized environments.
I also wanted to just sort of add in both of you while sharing about technologies. I feel like there's a lot of people centricity, even in terms of operations, right? Like even from what Dr. Karve shared, in terms of making it easy for a person to stand up, have access properly, make it easy for you to harvest the biochar, or for that matter, not having pits that are 6 feet deep. Very quickly, if we could just sort of share some insights on that.
Yeah, well, the biocharring technology was originally developed in the early 2000s with the objective of creating livelihood options. And it was focused at that time on agricultural waste, which didn't happen because, with time things changed. And in Maharashtra now, there is, in rural areas, there are more jobs and less people. So the new livelihood options are no longer viable here, but it has been taken up in other less developed states and has succeeded there. But then people started approaching us with this problem of urban waste management, and therefore we scaled down the system. It is a labor intensive system, though. I mean, that is one issue with biocharing. But the larger kiln that I showed, there, I mean, for a small kiln, you can operate 2 kilns with 4 people. And the large kiln, although it handles much more waste, just a couple of people can handle that entire system for dealing with about 200 kilograms of waste on a daily basis. So the labor component goes down as you increase the size. And now between these two sizes, any variation we can design. So customized designs are also possible. But yes, I mean, the whole idea at that time was that if manual labor is going to be used for operating this system, then we have to make it as easy and as safe for people to operate this as possible. That is why you will find that there are other type of these metallic portable charring kilns are also there. But in many cases, you are expected to sort of turn everything upside down to empty a barrel or something like that, which is a rather a dangerous proposition. And that is why we came up with this idea of keeping the bottom open, so that you simply lift away the metal cover and you are left with char. You don't have to be juggling with burning charcoal. So simple things like that, which have been added on based on experience. But yes, I mean, that's an important factor there. um, with the flame and all involved, safety becomes an issue. Yes.
Yeah. So, well, to add to ergonomics and the kind of efficiencies that we can bring into waste management, focused on organic right now, but generally across the chain, right from collection to disposal, we really have to think about
Yep.
all the detailing in terms of how easy it becomes for the daily person who's going to do this job, which is most ignored in our overall systems, because the kind of bins that we are going to give, see the difference in the size of the bin and the weight that has to be carried can decide whether a composting system or a biogas system works or not. Because if the operator then takes it easy and then combines, ends up breaking the bins, or creating unhygienic conditions when waste is being carried around, obviously, uh, the blame is going to come on a decentralized system, because it's inside the compound, and all that unhygienic conditions will be then created. So we have to look at how, right from detailing the bins, the kind of trolleys that are being used, if there are multiple floors, how the waste is going to be transported, and ultimately now coming to the composting facility itself. We've seen that all kinds of tick mark designs have been set up in many locations, where the operator really has to climb on top of a 3 feet wall to unload the waste into the pit. The pit is so wide that he can't even reach the other end of the pit. He can't harvest it, or it's located in a basement where it's literally he can't see anything. All of these things, because waste is such an ignored subject, we tend to think that, you know do the least and put it as far away as possible away from site, that let it be managed somehow. That's really not going to work. And if we are going to use decentralized methods, we really have to think about the people who are going to be working there daily, and to ensure their comfort and their efficiency, and to make it easy and simple for them to work. And then you'll notice that the systems then really tend to work, and they fall in line and can run for years, and give you very good results. So I think these factors definitely play a big role.
Yeah, and I'm sure like you would also hear from customers, right? Both product users and service users, in terms of the benefits that they're sort of getting. and sort of just summarize very quickly on that, and then we take on some questions. So again, same order. Dr. Karve, you first.
So we have been promoting this biocharing solution in the urban context only over the last 5-10 years, and really takeoff is happening only recently. But many bungalow owners have gone for this solution, and they are operating it themselves. They find it fairly easy to operate the small kiln. It becomes a sort of a family activity over the weekend. So that there is that bunch of people. When it comes to housing complexes and societies, everybody has to agree on the solution and all of that. So that uptake is slow, but there are a few the complexes which have gone for this, and well, haven't received any complaints so far. So, so I'm sort of assuming that it has worked fairly well for them in this winter season. As I said, for agricultural and forestry waste management, that is another area which we hadn't thought of. But the in fact, the large kiln that I showed you the photographs of, that is in operation in Meghalaya to deal with pine needles. Forestry waste is becoming another area where this solution is being favored. So there also people are quite happy with the performance and the output. And of course, the char briquettes we have been promoting for a long time. There are quite a few dedicated users now of this, what we call, it is a renewable charcoal fuel in that sense, because you are replacing wood charcoal with something which is made from waste material which would anyway be disposed of. So in that sense, it is a renewable form of charcoal. That idea sort of is catching on. The air freshener and the soap also, the customers are quite happy with these products. Overall, I think the technology has now reached a level where we can confidently say that it will do what it is expected to do.
Yes, so well, on our front, I think when it comes to composting, we are providing a service to largely to residential communities to begin with organic waste first, and really eliminate this waste stream from going into the municipal system. That is the first priority. And obviously, there we look at let me put some costs into context just to kind of also address this topic, because generally, I'd like to say that sustainable waste management is literally affordable for anybody in a real sense. And it's not really cost challenge, because only it's a challenge when it's compared to I would say, a free service of just collection. And generally, free services tend to be far more expensive finally in the end, because then you have to pay for the environmental cost and the externalized costs at the end of the day. To set up a system like this can cost like anywhere between 3,500 to 4,000 rupees a family. That's like one restaurant meal for a family, and a good restaurant meal. And let's say getting service on this would be somewhere between 80 to 100 rupees a month per family, to ensure that this is sustained long term. And that's where I think that's like 1/5 of the cost of a Tata Sky subscription. Okay, so I'm saying affordability is really not the topic, and that's why if we set the context in terms of how governance is looking at waste management in the future, it's pretty clear that some good policies are in place right from the central government. The idea is to decentralize organics management, and it's clear that everybody, all large institutions, housing complexes, restaurants, all of them will have to deal with this on their own in the future. So the sooner people get into understanding this quicker and be there to participate in this wonderful approach, I think this is going to take our society and our country forward. I mean, I have no doubt about it. In terms of the kind of climate impact that it has, it's staggering. I mean, it's 60% of waste going out of the system and actually generating resources at your doorstep is a game changer. And that's how we see it. And I think there was a question also that, the resource value is definitely possible to use. We have seen communities whom we are working with now 6 years, 7 years, they've gotten so used to the compost that's being generated in their compound, using it in their pots, seeing the flowers bloom. We recently got a call from somebody who said, I've seen this entire society look so green because of the compost. Just, start in my society. So, there are so many other benefits that come out of finally a sustainable approach. And only sustainable approaches ultimately are going to be that, the complete 180-degree reversal of climate change. What is actually a problem suddenly turns into a solution completely on the other side. And Dr. Karve, I think you will agree with me, both with biogas technology and biochar also are game-changing technologies. If all of them are really adopted at scale, I think the kind of resource savings that we would do as a country, it just blows my mind actually.
Great, thank you. So we'll open up questions. There's some in the chat box. The first is cost of kiln, and can we use the gas to light up the parking lot? And I think they mean biogas here from Srilata. Dr. Karve, if you'd like to respond.
Yeah. So the cost of the small kiln that I showed is 10,000 rupees, and the large one is 2 lakh rupees. And as I said, we can design now everything in between these two sizes based on what is the requirement. So that's the kind of costs, capital costs we are talking about. But these are made of iron, and carbon dissolves in iron. So eventually the kilns will burn out. So every 2 or 3 years, you may need to replace them. And that is why the economics has to be worked out in the local context as to what exactly, how maximally you can benefit from the char that is being produced by using it for which application. As far as the biogas is concerned, in a decentralized solution, the best use for the biogas is to use it for cooking, because to convert it into electricity you have to feed it into a generator, and so that is an additional cost. But there are electric generators which can take biogas, and for every I think every kilogram every cubic meter of biogas you get 2 units of electricity or something like that. But in a decentralized context, the cost doesn't justify this approach. So best is to use it for cooking. This solution will work best. I mean, there are now many places where you have a housing complex and you also have some commercial establishments. So if one of those commercial establishments is a restaurant, then sell the biogas to the restaurant. They are paying commercial cost for whatever gas they are using, so you can charge them higher for it, and that will take care of the cost of the biogas system. So that way also it can be worked out. Institutional campuses, they can use the biogas in their canteens and things like that. Or as I said, out of say 100 families, 5 families kitchens can be given that biogas. So those type of solutions, but the gas will have to be sold to the user to earn some money to recover the cost of this waste management. So those are the better approaches than going for electricity generation.
2 questions on burning of biogas. So, what about smoke or gas produced after burning these waste charcoals? How is biochar burning of waste different than incineration?
Yeah. So, firstly, char always burns more cleanly than the raw biomass. In the process of making char, a lot of the pollutants have already been driven out and burned off. The one issue with charcoal burning is that it can produce carbon monoxide, larger quantity than, let's say, burning wood. But typically, and that is also one of the reasons why use of charcoal as fuel is generally an outdoor activity. And in the even when you are using something like our steam cooker, in the Indian context, we don't live in insulated houses, so typically kitchens are fairly well ventilated, and the quantity of fuel we are using in a well designed charcoal fuel device is so small that it is not that harmful. But don't use the charcoal. I mean, you start a charcoal stove in the house, close all the doors and windows in winter, and go to sleep. I mean, that's a recipe for mass suicide. So don't do that. So that is something to be avoided. But for cooking, it's not such a huge big issue. Also, you have to understand that wood charcoal, generally the merchants will pour water on charcoal. The water gets absorbed in and increases the weight of the charcoal. Outside, the charcoal looks dry. You bring it home and start burning it, and it produces a lot of smoke. This char briquettes which are produced the way we are doing it, you cannot adulterate this fuel in that fashion, and therefore it burns very cleanly with very little smoke.
Okay, question for Pro Earth. Do you buy manure from societies? That could be a good revenue for them.
I think I didn't answer one question, but I can do that.
Oh, sure.
The one about incineration. Yeah.
Yeah, so maybe quickly, yes, we do buy the generated compost is owned by the waste generating community, and we buy it back. For there are ways that we are able to take it back to offset some of the operating costs.
Yeah, maybe the question on incineration versus.
Yeah. So in incineration, what is done is that whatever, firstly, when you are going to incinerate it, there is no botheration about whether it is segregated or not. So typically it will be a mixed waste which gets incinerated. It is heated to a very high temperature, and you get ash and some polluting gases, some of which just escape into open air. This is also a process which has to use some external energy source, because you are going to heat the material to a very high temperature. So again, it doesn't fit into the principle I stated earlier, that you don't want to spend energy to deal with waste. Whereas here what we are doing is that in the kiln, the temperature hardly goes to about 200, 300 degrees centigrade. As I said, you are not burning the waste directly. You just burn one layer, and then the gas will start burning at the top. That heats up the lower layers. And this is a compound. What you are dealing with is a compound of carbon, hydrogen, and oxygen. When you heat it, some of the carbon, hydrogen, oxygen compounds will be driven out in the form of gases. These gases, the moment these hot gases come in contact with air, they burn off. What is ultimately left behind is nearly pure carbon. So we have got tests done on the char that we produce, and we typically get more than 95% carbon in the material that comes out of the charring kiln. Whereas what comes out of the incinerator, the solid material, is just ash. All the carbon is burnt off there. So there is a fundamental difference between the chemistry of these two processes.
Someone had raised their hand. If they would still like to ask any question, then, please do raise your hand again, and then feel free to unmute and then ask. Okay.
Yeah. Am I audible to you, ma'am?
Yes. Please go ahead.
Ma'am, by the time we convince our societies for the same, like for buying and applying this technology, what could be the effective solution? Like till the time they buy, can they dig out the space or something like that, which would really be practical for the time being? the time they realize the importance and the time we get output from the same waste materials which are generated by the garden.
So, well, what I would suggest is you don't have to necessarily think about buying the kilns. You just hire Pro Earth, and they will provide you the total solution, which includes composting and biochar. They will take care of all the other part.
Okay. Okay. Thank you. Thank you.
Well, if I can just add to that, the point is, I don't know if I understood your question correctly. Are you really looking to? Are you saying that? I mean, until a decision
I
comes
think
from
it's,
the
yeah,
entire
because if
society.
there is, so see, if there is capital investment,
Yes.
then there is always a long time.
There are a
to
lot
take a
of norms
decision.
in societies, you know,
Yeah.
to
Yes.
But to hire a service is relatively easy. That's what I'm saying.
Yes.
Yeah, that could be a solution. But even hiring solution, this kind of solution, societies have a lot of committee members and there are a lot of constraints, you know. So
Yes.
by the time, if ma'am could suggest any effective solutions which are really practical.
So then I think the only solutions are for those people who are already convinced. Maybe you could begin with like home composting, for example.
Exactly.
That could be a solution, or even an individual level biogas plant which you could set up at home. So that you can convince further in the community that these are actual technologies that can work even on your balcony. So obviously it will work at the community level when designed and set up correctly. So I think this could be one approach where individuals take control of those people who are convinced and really bring a certain kind of advocacy inside the community to really push these ideas. That is really the approach to take.
Okay, and what about the lot of material which is generated into the garden? Like for our home-based composting, we can work accordingly. But what about the large generation of leaves and some waste materials, dried twigs and something like that, which people won't carry to their places? So for that, any simple suggestion for that, please?
So we do have a gasifier cook stove, which is also based on the same principle as the kiln, even a smaller version of that, which you can operate on your balcony and use some of the garden waste there. But I mean, collectively in the public space of the building, if this waste is being generated, then collective solution will have to be found for that. Somewhere, I mean, some level of an agreement has to be reached. Unless everybody agrees that just burning it up in smoke I mean, that is the cheapest solution.
Yeah, but few people, a lot of times, you know, they object for such burning and all that. Because
Exactly. I
sometimes,
mean, of course, they should.
some people have
The
health
municipal
issues, and
corporation will also.
even we are one of them.
But
It's not
but if
allowed.
you are not, if as a community,
Yeah,
there is no willingness to invest any amount of money in
they can invest, ma'am, but
waste
by the
management,
time, yeah,
then I mean, then you let the waste pile up. That's the only solution.
yeah, because what we are observing, they're mixing it up with just wet garbage, dry garbage, and they're sending it into government. These things, the vans that comes and collects it, but that won't give any sort of compost or something. So we really feel bad. But even when they burn, we are one of them stop burning this kind of things, because plastic always gets mixed up and that smoke
Yep.
is
Yeah.
really irritable. So I was asking.
Yes, so I can, other thing I can suggest is while a decision is kind of expected, or while you're working on trying to find a community solution, the best thing to do is to avoid mixing waste. That is the best thing you can do until then. So
Yes.
for example, let's say garden waste is piling up. Make sure that you bag it, you keep it in a neat and tidy way. You organize it. Don't allow it to get mixed with other materials, because then when you find a solution, if your waste is already mixed, then you'll have to spend a lot more to get it sorted out and organized. So the idea is to really look at making sure all your waste streams are sorted, separated, and in the meantime, you could do things like collection drives which don't cost
Okay.
you could invite us to your community
Yeah,
to
that would be a great
organize
idea.
awareness drives, collection drives, all
Hmm.
of that, where decisions are simpler, where money is not involved, but still you're moving into a direction that is sustainable, and there's a roadmap towards it. I think that's really what you can think about.
Yes, yes, yes. That could be effective. Thank you so much.
Thank you. I'm just sharing a couple of videos also on the chat box for everybody to refer. The first one is, of course, the biochar kiln, how it works in operation. So that's a video by Samuchit. Any other questions? If we have, we could sort of just take them, or sort of close the session. We really exceeded time. Anyone else?
Somebody wants a contact number. I think ProEarth's. Yeah, you have put there. Yeah.
Yeah. Thanks so much, Dr. Karve and Anil, for gracing this webinar. I think very insightful. Lots of, I would say we had a good conversation about how we need to really relook at our organic waste management, how we need to redesign our spaces, how we need to relook. I'd like to take a moment and thank Youth Alliance, who've been very generous with their paid Zoom subscription and have helped a social enterprise sort of use Zoom for about over 2 hours. So special thanks to them for that. And thank you everybody else who has been a great participant. Yeah, Anil.
Yeah, thanks. I'd just like to, I think, just thank everyone again for participating. Thank you, Dr. Karve, for really giving your time on this very interesting subject. And I hope all of you have got some insights onto the various technologies that can go into organic. Looking forward to being in touch. Thank you so much.
Thank you. Thank you very much.
Thank
for
you.
this
Thank you very much. Bye.
Bye.